Well, I grew up in southern Wisconsin on a dairy farm, and growing up I was very intrigued with all the equipment we had on the farm. And then I got to high school and I liked math and physics a lot, and I realized that all of this equipment had equations and mathematics that described it, so that's how I really got interested in this subject. And so I decided I wanted to be an engineer, and I went to a small school in Wisconsin and got my BS degree. And while there, the Amoco came and invited a couple students to work in the oil fields. Well, in Wisconsin we didn't have any oil, so I thought that would be pretty neat. And the first year after I went to Kansas and worked in a real old oil field. But the second year I went to Duncan, Oklahoma. It was kind of a drilling boom going on, so it was a lot different. The wells were being drilled, and it was new, and it was really exciting. And they took me out on a very deep gas well, and this well was 15,000 psi well. And I'd never seen such a big piece of equipment going up on that rig. But that's what convinced me to spend my life on drilling research, because it was such an intriguing subject. And then I went on and got my PhD at the Colorado School of Mines, and that was quite exciting for me because it's the first time I ever was involved with research. Then I decided when I graduated from there, I wanted to go in the oil business, but I applied for 2 jobs. One was with Corning Glass at the research center in Corning, New York, and the other one with Exxon in Tulsa, Oklahoma, at one of the research centers. And they both offered me jobs, so I went into the oil business. I spent my life in drilling. I think I'm the only person in the world who spent 50 years doing drilling research. Yeah, Exxon had 2 big research centers, one in Tulsa and one in Houston. And luckily I went to Tulsa because I met my wife there. But then we got transferred to Houston. And I was there 13 years until 1974. And I was really interested in horizontal drilling. And that isn't something a big company would do. And so I left and formed Maurer Engineering. I wanted to bring horizontal drilling from Russia to the United States. We could only drill vertical wells, but the Russians started publishing articles where they would drill a vertical well and then branching off, and some of these branches went horizontal. And really, we had nothing in the U.S. that could do anything like that, so most of the engineers thought that they were making it up, that it was not real. We didn't know how the Russians were drilling horizontal wells, but we learned about in the late 70s that they were using electric motors, and these motors came from the electrical submersible pump system. If you take the pump off and put a bit on, you got a drilling motor. But the really neat thing about the electric drill was that it had a power cable going up to the surface. So when you put electronic instruments down there for guiding it, you had instantaneous communication to the surface. Teleco started, we didn't have a way to get a cable in the pipe, so they used what they call mud pulse. And I know everybody, drilling engineers know all this, but there's a valve on the bottom that pulses. And it's kind of like a telegraph in principle. You can send digital data to the surface, and it may take a minute, or in the old days it did to do this. But you can't drill a hole accurately unless you have survey sensors in there. So the real key is you had to have a way to send that signal from the bit to the surface. It's our communication system. A man named Ralph Spindler with Teleco started working on MWD systems in 1972. And that was the one tool that I knew that we had to have to drill a horizontal well. And he worked on it a couple years, and I was doing a lot of work advising the Department of Energy, but it was called IRDA and other names in those days. And they came to me and asked me if they should fund this project, because Teleco knew that if they could get money from the government, 5 other companies over here would join the project. And we felt very strongly that they should, and advised them of this. And so they went ahead and started this really were able to commercialize that project because of that money. And about 5 years after that, I visited Raymond Engineering, who started Teleco, and they said the CEO wanted to see me, and I went in there, and I was happy to talk to him, but I didn't know why. He said, Bill, he said, if you hadn't told the government to fund our project, we would have terminated it. And he said, I just want to thank you, and that was pretty amazing to me. But it kind of chilled me, because the whole drilling systems we have now came from that MWD tool. Here was kind of the sequence of events. So I resigned from Exxon and formed Maurer Engineering in 1974, and we worked on all kind of advanced things. Then as we went along, these motors were developed, and all these tools were developed from 1975 to 1985 was really the golden age of drilling technology, because all of the tools we needed for horizontal drilling were developed in that period. So first of all, we had the MWD, and then the second thing was we needed those drill bits, and so I worked with General Electric, a man named Malin Dennis. He invented the PDC cutters we use on drill bits, and we built the world's first PDC bit when I was still with Exxon in '74. In 1979, I encouraged the government to drill a horizontal well, and they drilled a very shallow one. They started near the surface, and they drilled out. It was a 1,000-foot radius turn. And we call that long radius. It's not the optimum system. But what they did was they drilled this well. They took 3 or 4 months to do it. They didn't drill out very far horizontally. They spent $1 million on that well, and $1 million in those days was like 10 million now, which was a lot of money for them to spend on one well, you know. But they did it, and it was a historic well. Joe Passini was with the DOE, and he drilled it. And what it was the first horizontal well in the world outside of Russia. So nobody even remembers this well, but it was very, very historic, okay? Then, about 2 or 3 years later, Ajip started drilling horizontal wells in the Rospo-Mary field. And this really caught the attention of the world, because they would go down and go out 1,000 feet or more. I don't know exactly how far out. But they demonstrated, one, that an oil company could drill a horizontal well in a real field, a real oil field. Number 2, they increased their production a lot. So this really got everybody excited about horizontal drilling. I visited Frank Shue. Frank was the top guy in the world on casing and tubulars and the stresses. And I went up to visit him at ARCO. And this was about 73 or 4. No, I mean 83 or 4. I said, and Frank, I started telling him what we were doing with these motors, these little motors. We started a company called Slim Drill, and we became the world leaders in guiding these little holes. And he said, Bill, I'll tell you what the problem is. He said, in our oil field, they drill these 1,000-foot turns, but by the time you get horizontal, you're 1,000 feet away from the rig. And he said, the drilling of that is extremely expensive. He said, I've studied the problem. He said, what I need is to turn that in 300 feet. And what that means is you're vertical in the well at one end of a football field, and when you come out at the other end, you're horizontal. And he said, it's a difficult problem. And I said, you know, we're doing pretty high-angle wells, and I think we can do it. He said, can you do it? And I said, I think so. So we went back and ran our computer programs and everything, and I contacted him a couple of days later, and I said, Frank, I said, we think we can do it. And so he said, if you bring the tools up, I'll test them. He said, I'm drilling with a Christensen motor trying to do it into a big quarry, big quarry. And so he said, we can step back and drill out and see if how it's coming out properly. And so I took him up there 3 months later, and we drilled with it, and it worked perfect. And so then that was Frank. It was really Frank Shue deserves the credit for coming up with the idea, and we call that medium radius. We call those long ones long radius, and so this was really a big breakthrough. And I don't think Frank ever got the credit for doing that, and so I'm real happy today to say, if it weren't for Frank Shue, we wouldn't be doing it. And but we built the motors to do it, and so we went out and drilled the world's first medium radius well, and all wells are now medium radius, okay, in the Austin Chalk. And we drilled out about 300 feet. We hit a fracture. It had so much pressure in it that it just about blew out the rig. And luckily, Bill Ream was on the rig, and he wrote all the well control manuals, and he brought it under control. And so Bill Ream deserves a lot of credit for working on that first horizontal well. But then what happened, well, Frank Shue also said, you know, I just started the DEA, and he said he explained to me what it was, where companies came in with an idea and you get a lot of companies to fund it. And he said you ought to really expand your program you're doing on extended reach drilling and do horizontal drilling. And this was in 1985. But what was really important was that when you have a new technology, you always have a lot of problems, okay? It doesn't matter what it is. But what we did was, every time someone drilled a well on this project, we had a top drilling, world-class drilling guy out there, and he identified every problem that they arose, all the things they tried to solve it with, and what solved the problem. And in this way, everybody was drilling their wells that had a different problem, and you eliminated all these problems. Whereas if one company like a Shell, they would have had to drill 10 years to solve them. But we could solve them in a year because we had 30, 40, 50 companies drilling all these horizontal wells. And I think in reality, it was the most successful joint industry project ever in the oil industry. And because it accelerated horizontal drilling so much. And if we hadn't had that, we'd probably be about 10 years behind. So this worldwide shale boom would not exist. And I think that's, of all the things we did, that's probably the most important because it's changing the world, you know. Well, there's been tremendous breakthroughs in all fields. The geophysics, first of all, you know, they just can do marvelous things. And in the production engineering, let me give you an example. When I came into the industry, we only knew how to drill vertical. And the average drilling rate was 17 feet an hour. Now we drill this 8-mile holes. These people do, Exxon does. And it's just, the shale wells are amazing. These Eagle Ford wells, they drill down, they drill out a mile. They do that in 20 days and they frack in 30 days. If you would have done that when I was a young engineer, it would have taken a year, or it would have taken a long time, you know what I mean? They didn't know how to even do it, but it's amazing. But the most marvelous stuff has been offshore. They were probably drilling in 500 or 1,000 feet of water, and now they're drilling in 15,000. It was just unheard of to do anything like that. And the size of these ships and stuff, it's truly amazing. You wouldn't think it could be done. When they got deeper, they'd have these floating drilling rigs, you know, and they're so large. And then you have to have this riser. It's very heavy and goes down 10,000 feet of water or more. It weighs a tremendous amount. And just the fact that they can complete these wells on the seafloor. And I saw a lot of that develop when I was still with Exxon, the seafloor. Can you imagine going down 2 miles of water or something, or 3, and putting all this stuff down there, and then if it breaks, you have to remotely change the valves and stuff, and it's amazing. I think the next big breakthrough will have joystick drilling, what I'd call joystick drilling guidance, and computer controls, and the humans will be removed from it. The computers will control everything, but they'll override it if they get into a problem. But right now, there's still the humans make all the decisions on how you're going to drill the well and how you do things. But if we can remove the human from the loop, we will be a lot better off, and it'll be all automated. I think another thing too is I didn't mention, we had studies 40 years ago about drilling from tunnels, like in the Arctic and that. And I don't know if you know it, but Shell just spent a fortune, and they gave up about Arctic drilling, or at least it's a big problem. But I still think we could go down and put tunnels in and drill from tunnels. And then you just have a land rig, which doesn't cost much, and it's nice and warm. You don't have to worry about the elements. You don't have to worry about being offshore. They're doing some of that offshore, you know. Instead of drilling from offshore onto land, let's drill from a tunnel toward the water. As I mentioned earlier, back in the 70s, we drilled pretty deep wells in East Texas with a rig that was modified to 10,000 psi, and we could drill 3 times as fast. But I've been working with some companies now. They're building very small. They have a drill that's a 1/2 inch diameter, approximately, and they can drill out from a well bore, a little hole like that, 300-400 feet. And if you go 300 or 400 feet in a lot of directions, you might intercept fractures, or you provide a good pathway to a well bore. In these horizontal wells, the fluid comes in, and it may come 1,000 feet or something and come in, and all at once it goes in a 6-inch circle or something. So as it comes in, it starts plugging things. And they think that this damage zone around these horizontal wells reduces flow rate by 35%. But if we could put a bunch of 1-inch holes, and they have slots that go out 3 or 4 inches around them, that you could produce 35% more oil instantly. And so this is something we have to do. So, see, oil may have sand and stuff in it, and it's okay out here because it's moving slowly, but the closer it comes in, the faster it's moving. It may move 1,000 times faster around that 6-inch hole that it is out here, and it builds up pressure and packs up those solids, and it damages these wells. So I think we can do a lot with these little jet drills to overcome that problem. Number one is working with really outstanding engineers all over the world. And I think number two is helping a lot of young engineers reach their full potential. A lot of people never reach their full potential. And we have guys who worked with us and went out to other places, and they're doing extremely well. And I think, you know, you get a satisfaction of making this a better world, and I think that that's what everybody tries to do. You know, if we can produce all that oil from the shale and become energy independent, I mean, that's unheard of. It wasn't in the wildest dreams. Nobody thought that we would go from importing 60–70% oil to potentially zero. That's amazing. And having been a little part of that makes me feel real good. Yeah. You can develop the best widget in the world, but sometimes it's hard to get implemented. And we found that if you have something really new, the best way to do it is start a company, get it out in the marketplace, you know, so people, and then sell the company and use the money to do something else, do another one. Yeah. But it made it, gave us lots of satisfaction, because we would start a company, it wasn't worth anything on paper. We'd give a guy, pick the top guy in the industry to run it, give him 25% of the company, and before you know it, you have a really big thing growing, you know. And I feel really good for all those guys who we did that with.